Good morning. Can you hear me?
Good afternoon.
Okay, Akash. Sheetal, can you hear me?
Yes, sir.
Okay, Sheetal, what about your lectures in your own department? Have they started?
Yes, sir. They started, but they're not taking properly.
Okay, properly means what? Not on scheduled times, no fixed time.
No fixed timing.
Okay. And how many subjects they have started lectures? All the four?
No, sir.
Okay. Instrumentation paper has started.
Yes, sir. They have started.
Okay. Who is teaching that?
Khobragade, sir.
Okay, okay. So do you find my lectures useful?
Yes, sir. I find.
Okay, okay. We'll wait for a couple of minutes so that most of the students will join. Okay, shall we begin?
Yes, sir.
Okay, everybody can hear
Good
me, I
afternoon.
suppose. Okay, so in today's lecture, we are going to see about the pH meter. Okay, this is again one of the very important instruments that is covered in your syllabus. Okay, but before we go to the instrument as such, I would first like to introduce you to some important concepts. We will try to understand what is the nature of water, water molecule, how it, for example, how in what kind of a form it is, in a dissociated form. Okay, then we will also understand what is an acid, a base. I think these are some things which you already have studied in your college days. Okay, we will also try to understand what is a buffer, and only after doing that we will try to learn about the pH meter. Okay, so I go to the next slide. I hope you are able to see my slides properly. Okay, this particular slide
Yes, sir.
tries to describe what is the molecule of water. Everybody knows that water consists of two molecules of hydrogen and one molecule of oxygen. Okay, so it is H2O. But very important thing that you should know is that these atoms of hydrogen, two hydrogen and one oxygen, okay, these are not always associated, uh, not always associated together. Okay, but rather the association is of a transient nature. Can you see this word here? Transient nature. Okay, that is to say, there is association of these atoms and dissociation which takes place constantly. Okay, and at any time there is an equilibrium. This is an equilibrium mediated process. Okay, and therefore the number of water molecules H2O and the number of hydrogen, that is protons and hydroxyl ions, these numbers always will be in a kind of a balance. Okay, can you understand what I'm saying? And therefore I have written here an equation H2O. Okay, and then I have shown here two arrows, the forward arrow and the reverse arrow, indicating that water molecule can dissociate into the protons and hydroxyl ions, and these ions can again associate together to form the water molecule. Okay, and then we should also know what is an acid and a base. Now I think these are terms which you are already knowing. Okay, so acid and a base, they cause burning of the skin. Everybody knows about it. Then acid is something which turns the litmus paper red or pink, and a base is something which turns a litmus paper blue. Okay, so red turned into blue or blue converted into the red color. These are the characteristics of the acid and the base. Then we also know that an acid or a base, when they're added to water, then they will immediately ionize. Okay, so acid is something which ionizes and gives rise to the protons or H plus ions, and the base is something which will result into the hydroxyl ions. It will produce the hydroxyl ions when it is added to water. Okay, then we also know that there are some things which are called as strong acids and weak acids, and there are strong alkalis and weak alkalis, or strong bases and weak bases. Okay, so the strong acids and strong alkalis are something which produce which will immediately dissociate in water, and therefore they will produce a large number of ions. And the weaker acids or weaker bases will not dissociate completely in water. They will dissociate partially, and therefore they will produce less number of ions in the water. Is it clear to everybody? Okay, then in my next slide, I have given you some examples of some substances, okay, which have acidic or basic properties. For example, milk of magnesia. Do you know this? What is milk of magnesia? It has a pH of 10.4, which is a very alkaline pH. Okay, it is a strong alkali. Can you hear me?
Yes, sir.
Okay, so what is milk of magnesia?
Tree milk, bark.
Yes, that is magnesium hydroxide. Okay, magnesium hydroxide. And do you know the uses of this magnesium hydroxide or milk of magnesia? A very common medical use of this particular substance is as an antacid. Okay, it is an anti-acid because it is an alkali. Okay, it is used for some digestive problems. Okay, pH of this is 10.4. Then the pH of blood, you might be knowing, is slightly alkaline. It is 7.35. Distilled water, of course, the pH is 7. Okay, it is neutral pH. pH of milk, coffee is slightly acidic again. Then maybe Tikekar sir has told you that the pH of beer is quite acidic, you can say pH is 4.4. Then some of the fruit juices like orange juice, for example, also is very acidic, 3.7. Vinegar is 3.2. And the colas that we usually have during the summer seasons, the pH is very acidic, it is 2.8. Okay, so this is just to tell you some interesting fact about the substances that we use daily. Okay, and then the next thing is what do you know about the applications of pH measurement? Okay, have you ever done pH analysis or pH measurement in your laboratory? Shubhangi?
Yes, sir.
Hmm. You have used it. Okay, so what was the purpose of determining the pH?
No, sir, I'm only doing this on the litmus paper.
I couldn't hear you properly. Your mic, I think, is too close to your mouth. So just hold it a little away, then we can hear you.
Sir, I'm done only on litmus paper.
Okay, okay. You have checked the pH using litmus paper. Okay, but what was the reason? What was the application of that?
Sir, acidic or basic
Okay, you wanted
solutions.
okay, you wanted to know whether a particular liquid is
Fine.
acidic or basic. But what was that liquid? Can you tell us?
Yes, sir.
What was that?
Mixture of H plus or H minus ions.
Okay, what was the liquid? I want to know.
Sorry, sir.
Hello.
Sorry, sir. I don't get it.
What was the
Yes,
kind
sir.
of
I don't get it.
what was the solution that you were using? Was it distilled water? Was it your microbiological medium? Or was it some other liquid?
Sir, I don't remember.
Okay, you don't remember? Well, anybody else who want to answer?
Sir, I have used this during preparation of different microbiological media.
Okay.
In this,
Mhm.
different microbes are grow on media having a particular pH range. So
Mhm.
I was using during these preparations,
Okay.
and another
फिर
during
बफर प्रिपरेशन कितने टाइम सर किया था?
Very good. Okay, you have prepared buffers. Was that Vaishnavi who was answering?
Sir Pragati.
Okay, Pragati. Okay. So who else wants to say something?
In the microbiology class preparation,
Yes.
I use this.
Wonderful, wonderful. Okay. So even I have written some applications on this slide. Okay. So if you are comfortable, you can use these applications, or maybe you can write down your own application that you have already done in your laboratories. Okay. For example, neutralization of the industrial effluent which come out from steel industry or paper and pulp industry, because these effluents are either highly acidic or highly alkaline, and therefore they cannot be disposed of into the water streams just as it is, and therefore they have to be neutralized. Okay. And then you see, when they are neutralizing such effluents, it is necessary to know what was the initial pH and what is the final pH, whether neutralization has been achieved or not. Okay. Then coming to this application, the food and the food and beverage industries also require to control the quality of the food, and therefore they also use the pH measurement. Okay, pharmaceutical industries, then in the microbiological industries, microbiology based industries, or in the microbiology based laboratories also, like Pragati has already said that for the preparation of microbiological media, we use the pH meter, or we check the pH using some other things like the pH paper. Okay. And then Shamim, I think Shamim told us about buffers. Okay. Buffers are very commonly used in biological laboratories. Bioprocess industries or different enzymic reactions also require that the pH must be controlled. Okay. And therefore the pH measurement is very much essential. Then this is something very interesting. Do you know that that eye wash, okay, consists of boric acid? Okay, 5% boric acid is used as an eye wash. Okay, and then my question is, why do we use boric acid? It is acidic in nature, indeed. Okay, but it is
Antiseptic.
yeah. What did you say?
Boric acid used for antiseptic.
Yeah, it is also used as an antiseptic. Okay, so although it is an acid, it is used as an eye wash or antiseptic. Okay, but the question is, can we use the same concentration, that is 5% of H2SO4, as an eye wash? My question is, can I use H2SO4 or even HCl, hydrochloric acid, to wash the eyes?
H2SO4 strong acid maybe
Yeah.
compared to boric.
Yes, yes. Who is that? Who answered this?
Prashant sir.
Okay, Prashant, that is very good that you have told. Okay, we cannot use these acids, this is strong acids like HCl or H2SO4 or nitric acid, to wash the eyes. The reason is that these acids are very strong acids. Okay, whereas boric acid actually is a weak acid. Okay, and in a very short while we are going to learn about what are strong acids and what are weak acids. Okay. Sulfuric acid, okay, if we consider sulfuric acid, then this almost completely dissociates very easily, instantly it dissociates, and therefore a large number of protons are generated. Okay, and when large number of protons are generated, the acid is said to be a strong acid. Okay, if it is a strong acid, then it will definitely have a very harmful effect on the body or on the eyes. Okay. Now, this strong acidity or weak acidity properties, these are very often denoted by the term which is called potency. Okay, potency of the acid. Okay, this potency is actually the active concentration or the activity of the hydrogen ions. Okay, so it is as good as saying that the students are all very active, isn't it? All students are there. For example, how many are there in the classroom? I think there are 22 students in this batch, isn't it? In your class, is it 21 or 22?
22, I think so.
22, yes, 22 students are there in your class. But how many students are actually attending this lecture, today's lecture?
16.
16, you can see that, isn't it?
15.
15, yeah, including me, it is 16 actually. So the number of students is 15 out of 22, isn't it? So can I use this term active students? I can say that there are 15 students who are active, and rather they are actively participating in this lecture, whereas the other students, that is, I think 7 students are not active. Okay, so although they are in the class, they are not attending the lecture, isn't it? So similarly, I can say that a particular substance, okay, if it is an acid or an alkali, whatever it is, okay, it doesn't matter how many protons are there actually in that acid. Okay, what matters is that how many protons are active. Okay, how many protons are active. That is to say, how many protons are in the actual dissociated state. Okay, the number of protons which are in the actual dissociated state, these are going to render the properties of acidic nature to that particular substance. Is it clear to you?
Yes, sir.
So if I say that a particular acid is a strong acid like sulfuric acid or hydrochloric acid, then it essentially means that all of the protons are actually dissociated. Whereas if it is a weak acid, then it means that all of the protons are not, or all of the molecules are not in the dissociated state, and therefore the number of protons are actually very less compared to the total number of hydrogens which are present in that particular substance. Is it right? Okay, then let us try to understand something about water itself. Okay, pure water also ionizes. Okay, H2O ionizes. I think in the first part I have told you that pure water ionizes into H plus ions and OH minus ions. Okay, but the problem is, I won't say it is a problem, okay, but it is a characteristic feature of water that all of these molecules of water are not in an ionized state. Okay, water actually ionizes very poorly. Okay, very poorly. That is, only few molecules of water at any given time will be in the ionized form. What is the ionized form of water? H plus ions and OH
H
minus.
plus OH minus.
Yes, OH, H plus and OH minus ions.
Okay.
Are all the molecules of water in the dissociated state? The answer is
No, sir.
yeah. The
No,
answer
sir.
is no. Right? All the molecules of water are not in the ionized state. In fact, very few molecules of water at any given time are ionized. Okay, and then there is one more important thing that we should know. There are roughly equal amounts of H plus ions and OH minus ions in pure water. So if it is pure water, that is distilled water as we call it, then the number of protons and the number of hydroxyl ions is actually equal. Okay, and the concentration of each is not very high. It is actually a low concentration, that is 1 into 10 raised to minus 7 molecules. Okay, so if it is pure water, then there are 1 into 10 raised to minus 7 molecules of, or rather protons. Okay, 1 into 10 raised to minus 7 protons, and there are 1 into 10 raised to minus 7 hydroxyl ions per liter. Okay, per liter. Have you all followed what I'm saying?
Yes, sir.
Okay. Now what happens is,
Yes, sir. Yes, sir.
to this pure water, if we add some acid, Okay, if we add some acid, strong acid, for example, then what will happen? The acid will dissociate in water. Okay, acid will dissociate, and therefore the concentration of protons will increase. Do you understand what I'm saying? If I
Yes, sir.
add
Yes, sir.
acid to water, then that acid, if it is a strong acid, then definitely the acid will dissociate, and when the acid dissociates, it will give rise to increase in the proton concentration, isn't it? Because acid contains protons, right? So these protons will be added to water, and therefore the concentration of protons will increase, and at the same time the concentration of hydroxyl ions will decrease, because the product of protons and hydroxyl ions is always constant. Okay, now this product we call as the ionic product. Okay, product of protons and hydroxyl ions, that is, if we multiply the number of protons and the number of hydroxyl ions, that particular number is called as the ionic product. Okay, this ionic product will always remain constant, and that is 1 into 10 raised to minus 14 per liter. Okay, 1 into 10 raised to minus 14 per liter. Although I have written the term mole here, okay, molecules, okay, but we know that these are ions actually, right? So 1 into 10 raised to minus 14 ions per liter. Okay. Now this particular number 1 into 10 raised to minus 14 is also called as, it is a constant, and it is also called as Kw. That is what? The ionic product of water, Kw. Is it okay? Have you all understood what I'm saying?
Yes, sir.
Okay. Is there anybody who has not understood? If there is any confusion, please let me know. I have only 10 minutes for this particular session. Okay. Do you want me to repeat what I said already? Okay. I was telling you that pure water does not ionize completely. Okay. It will ionize to some extent. Okay. Partially. In fact, we can say that it is a poor, at a poor level, it will ionize. Okay. So pure water will ionize very poorly. Okay, and there are equal amounts of protons, that is H plus ions, and hydroxyl ions, that is the OH minus ions in pure water. Okay, and if you calculate the total number of the protons and the hydroxyls, that is the product, if we talk, I'm talking about, the product is 1 into 10 raised to minus 14 ions per liter. Okay, or we can also call it as moles per liter. Okay, we are talking about moles per liter. What is mole per liter? What is 1 mole of any compound? I think last time somebody had told me about 1 mole.
Yes, sir.
Yes.
So mass by Avogadro's number.
1 mole actually means Avogadro's number of molecules,
6.0.
6.023 into 10 raised to,
6.02. Not 10 to the minus 14.
not minus 14, 10 to the power
Sorry,
20.
14.
23.
23.
Yeah, that is the number of molecules in 1 mole of any substance. Okay, we are coming to that also. So what is the molarity of water? Do you know what is the molarity of water?
55.5.
55.5. Very good answer. Who is giving that answer?
Shubhang.
Shubhangi, very good. How do you remember that number? That is very good.
Sir, someone.
But can you calculate? Can you tell me how you calculated that?
No, sir. I know only.
Okay, you know only.
Someone tell me.
Okay, but can we calculate that molarity of water, pure water? How can we calculate it? Okay, I have this slide here. Just try to understand this slide. Okay, H2O molecule we are talking about. So there are two hydrogens. Okay, two hydrogen, and there is one oxygen, isn't it? Now, if you calculate two hydrogen, that is the atomic weight is 1 per hydrogen. So 1 plus 1 is 2 for hydrogen, and the atomic weight for oxygen is 16. Okay, so 2 plus 16 is equal to 18. That is the molecular weight of water. Is it right? Okay, everybody agrees to me what I'm saying. The molecular weight
Yes, sir.
of water is 18. Okay, now what I'm going to tell you is this 18 gram of water. Okay, molecular weight of a substance expressed in terms of gram. Okay, gram per liter, that is 1 mole, isn't it? Everybody knows that definition, right? So what I'm going to do is I'm trying to calculate it like this, that if 18 gram we take water, okay, 18 gram in 1 liter, that will be 1 mole of water. Is it correct? If I take 18 gram
Yes,
of
sir.
water in a total of 1 liter water, then it is 1 mole, right? But again, we know that the specific gravity of water is 1. Okay, and therefore if we take 1 liter of water, 1 liter, it actually contains 1000 gram of water. Interesting. Okay, so how can I take 18 gram of water in 1 liter of water? That is not possible, because 1 liter of water actually means 1000 gram of water. Is it right? Agreed,
Yes,
everybody, or no? Okay, see, I have 1 liter of water. It means 1 liter actually means I have 1000 gram of water, because the specific gravity of water is 1. 1 liter is equal to 1 kilogram of water. Is it right? 1 kilogram is 1000 gram of water. So now I want to know what is the molarity of water. So what I'm going to do is I will divide this 1000 by 18. 18 is the molecular weight of water. So 1000 divided by 18 is 55.5 mole. Is it right? In other words, if I give you 1 liter of water or 1 kilogram of water and ask you what is the molarity of that, then how many moles of water it is, then you are going to tell me that it is 55.5 moles of water. Is it right? Okay. The next question is, can we increase the molarity? How can we increase the molarity? There is no answer to this question. We cannot increase the molarity because this is the maximum molarity we can have for the pure water. Okay, pure water is 55.5 mole. We cannot increase it. Can we decrease the molarity of water? Can we decrease the molarity of water? The other meaning of this is that, can we dilute water? Water is itself used to dilute something. So can we dilute water?
No, sir.
Why? Why we can't dilute? Pure water is pure water. Now, can we dilute pure water? The meaning of this is that, can I make the water impure? Okay, if I make the water impure, then it is as good as saying that the water is dilute. Okay, so if I add something to water, if I add some miscible liquid to water, then water will get diluted, isn't it? And if water gets diluted, the molarity of water will decrease. Is it okay?
yes, sir.
Okay. So coming back again to this same question again, what is pH? pH is actually the measure of protons. How many protons are there in a substance? Okay, rather not the question of how many protons are there, but how many protons are produced in water. Okay, that is active protons. Okay, sometime back I told you that the active number of protons is what gives rise to the acidity. isn't it? And therefore pH is a measure of the active protons, and therefore this word is used. The potens, this is actually a French word, okay? The potens of hydrogen or the power of hydrogen, okay? This particular word pondus hydrogeny was given by a scientist, Danish scientist by the name SPL Sorensen. Have you heard this name, Sorensen? Okay. This
No,
is
sir.
Yes, sir.
this name is very important because the pH scale that we are going to see later, pH scale is from 1 to 14. Okay. That particular scale was given by this scientist Sorensen. Okay. And therefore the pH scale is also called as the Sorensen scale. Right. Now, as per the scientific definition of pH, okay, this is the definition. It is the negative logarithm of H plus ion concentration, negative log of the proton concentration. Have you heard this definition anytime?
Yes, sir.
Okay. So negative log of H plus ion concentration, in that term, we are going to measure the pH. Okay. We write it like this: minus log of H plus ion concentration. And then I have written this H plus ion in square bracket. So what is the meaning of the square bracket?
Concentration.
Concentration.
Why it is a square bracket?
Say it means concentration.
Concentration.
Okay, everybody agrees to this? Anybody has a different answer? Does anybody have a different answer? I am saying that this answer is not correct. Okay. Why we are writing the square bracket is very, very important. The square bracket indicates that this is not just the concentration of protons, but it is the active concentration of protons.